This is 2.6 transformations of functions. And what we're going to do is basically take functions and we're going to transform them. And something that is going to be very helpful for you is if you know the parent function. So you may want to pause this video and just notice the common parent functions. And we'll talk about the parent functions. And what we're going to basically do is take some of these parent functions and then we're going to transform them. A lot of times we'll talk about the quadratic just because it's easy to understand, but we could talk about any of these parent functions, and there could be a lot more parent functions, but these are the most common parent functions. And so we'll take that quadratic and we'll basically change things to it, and it will shift or translate or reflect in a different manner. And we don't have to use our graphing calculator to graph things. I'm going to show you how to transform based off of the parent function. So first of all, let's talk about vertical shifts. So vertical shifts, so if you have a function f of x, so this all starts with f of x, the function, and then if you have something like plus c, well, it's being transformed, or it's being shifted, I should say, shifted upwards that many units. Or if you have minus c, then it's being shifted downward. And you can see like plus c, so the original f of x is here, and plus c would be the red. So whatever the c is, I mean, it might be, you might have some example like x squared plus 4. Well, you're shifting 4 spaces up. Or if this was minus 3, you would be shifting it 3 spaces down. Whatever the function is, the plus or minus at the end shifts it up or down. So that's called a vertical shift of graph. So if you have an example like this, again, the parent function, you should be quite familiar with the parent function. So that's the parent function. And you should know that, a lot of the common, especially a parabola, you should know that. But notice what this is being done. You don't need to make an XY chart. You don't need to use a graphing calculator. This plus 3, see the parent function is there, but it's being shifted up 3 spaces. So you're basically taking each point and you're going to shift it up 1, 2, 3. And so now the vertex is here, and this point's being shifted up 3, this point's being shifted up 3, and so everything's being shifted up 3. So the parabola is going to look like that. Okay, it's the same parabola, but it's being shifted up 3 spaces. And likewise, this is being shifted down 2 spaces. So you literally just shift it down, and then the parabola is going to look like that. Okay, so that's what the number on the end does. It shifts it up or down. So let's talk about a horizontal shifting. So that was a vertical shifting. Let's talk about a horizontal shifting. So notice, again, this is related to the function f of x. So notice if I have something in the parentheses, a plus or a minus, it's actually, notice if it's minus, you're actually shifting it to the right. And if it's plus, you're actually shifting it to the left. So in other words, the opposite of what it looks like. And you can see the illustrations that I have here. X minus c is actually, I'm shifting it to the right that many spaces. So let's look at an example. So again, the parent function is x squared. So again, if I drew the parent function, so that's the parent function. So notice this right here, it says plus 4. Again, you don't need an XY chart for this. You don't need a graphing calculator for this. But that's actually being shifted 4 spaces to the left. So because it says plus 4, and it's inside the parenthesis, you're going to actually shift it 4 spaces to the left. So look at the vertex. So 1, 2, 3, 4. So now this is the new vertex. I've got to do that, and every point's being shifted 4 spaces to the left. So then you just basically graph it from that standpoint. This one is being shifted, it says -2, so we're shifting it 2 spaces to the right, so the vertex would be there, and then you just shift all the other points over like that. So that's a horizontal shift. Now, if I wanted to combine horizontal and vertical shifts, so again, the parent function is y equals x squared. So what if I did something like the 2 together? So what if I did something like x minus 2 squared plus 3? Well, remember where the original parent function is. So the original parent function is this. And So this right here is shifting it 2 spaces to the right, so you're going to shift it 2 spaces to the right, and this right here is shifting it 3 spaces up. So the new vertex is right there. So everything, all the points are going 2 spaces to the right, and this is 3 spaces up. But you can do the same thing, 2 spaces to the right, 3 spaces up. 2 spaces to the right, 3 spaces up. And so you can graph that parabola, just take every single point and then shift it. And it doesn't have to be x squared. I keep using the parabola as the parent function. It could be any parent function. It does not make a difference. You're just using that as an illustration. The parabola is a good illustration to always look at because it's a very familiar function. So if I had this illustration, again, the parent function, if you think of the parent function square root of x, that's the parent function. And then if you know what that looks like, so the parent function looks like that. And if you're not 100% sure what the parent function looks like, I mean, you could always do an XY chart. I mean, plug in 0, plug in 1, plug in 4, and so 0, 0, 1, 2. So that's how come you can easily graph those points really quick. Just make a quick XY chart if you don't know what the parent function looks like. But notice what the same thing is, you have a -3 on the inside, so it's being shifted 3 to the right. And this is 4 spaces up. So everything is being 3 to the right and 4 up. So if you take every point and go 3 to the right and 4 up. And then take this point, 3 to the right and 4 up. And so you can see the graphs like this. So it's the same graph, it's just being shifted vertically and horizontally. Here's another one. Again, the absolute value function. If you should know the parent function to be able to do this. It's absolute value. So the parent function is, it's everything's going to end up being a positive value. So, but notice this is being shifted 3 to the left and 2 up. So you're literally going to go, start at that little low point, and 3 to the left, and then 2 up. So that's the function that you're doing. You're just shifting it horizontally and vertically. So let's talk about reflecting graphs. Now, a parabola, a lot of times when we deal with the parabolas, we know it reflects about the y-axis, and that's a good parabola that we always look at. But to notice the graph y equals negative f of x reflects the graph of y equals f of x on the x-axis, and then the graph of y equals f of negative x reflects the graph of y equals f of x on the y-axis. Let's deal with the y-axis. So if it's dealing with the y-axis, and again, the parabola is the most common. You don't have to look at the parabola, but it's a very common function to look at. So if you notice these points, this is the point 1, 1. This is the point negative 1, 1. Notice the x's. Notice the x's on this. So notice all I really did was I took x and negative x. And notice I'm still going to end up with the same y value. And same thing here. This is the point 2, 4, and this is the point negative 2, 4. Notice the y values are the same, but the x values are just negative x and x. And the same thing with the x-axis. So the square root of, let's talk about the square root of x. So that function that we just graphed. So if we reflect that, on the x-axis, so notice this point is the point 1, 1, this point is the point 1 and negative 1. And notice this point is the point 4, 2, and notice this point is the point 4, negative 2. So notice here, the the y values are changing. So that's what it says, y equals negative f of x, or another way to look at it is negative y equals f of x. So notice that the y values are changing when it's reflected on the x-axis. So let's talk about vertical shrinking and stretching. So the other aspect of it is, like what if I'm multiplying by something, the function, it's going to end up stretching it vertically. So if c is greater than 1, so again, I'm just using this illustration, f of x, and we're just going to just say this is x squared, the common parabola we just keep referring to. But what if I had 4x squared? So what's that for? So if c is greater than 1, it's going to end up stretching it vertically by a factor of c. So whatever that 4, in this case 4, so you're going to stretch every value by a factor of 4 on that illustration. If c is in between 0 and 1, so what if I had, y equals 1/2 x squared? So if I had something like that, it's going to literally shrink it vertically by a factor of 1/2. So it's only going to grow half the value with a fraction in front of it. So here I have an illustration. Use the graph f of x equals x squared to sketch the graph. So again, if you have 3x squared, so here's the common function, x squared. I keep referring back to this, that's x squared. And 3x squared is literally going to like stretch it, almost like a rubber band. If you pull on a rubber band, it's going to stretch it by a factor of 3. So it's literally going to make it a thinner parabola. So and it's like this happens to be the point 1, 1, and for this point. And this one, notice it's 1, 3. So notice it's being multiplied by a factor of 3. This point right here is the point 2, 4. So the stretched graph will be 212 because I'm multiplying this by 3. So you go to 212, and you can literally just reflect it over here, and then you can graph it like that. Well, the same thing with this as being 1/3. So it's going to be a wider graph because of that. So in general, when you look at this, if this number is bigger than 1, it's going to be a thinner graph. If it's less than 1, like a fraction, 1/4, 1/5, 1/8, then it's going to be a wider graph to be able to do that. So now what if I had all of this right here? And I'm not going to be very specific with graphing right now, but in general, remember, what does this do? It's going to move it 5 spaces to the right. This is going to move it 1 space up. And this is going to stretch it vertically. By a factor of 2. So in other words, it's going to be thinner. So if I take a parabola and I shift it 5 spaces to the right, 1 space up, that's my vertex, and then it's going to be a thinner parabola. Now again, you can actually plug in points to actually graph it, but in general, that's what the parabola is going to look like. And then the same thing with this, without using a graphic calculator, without making a huge XY chart and just guessing a bunch of numbers, notice this is 7 spaces to the left, and this is 3 spaces down. So that's going to give me the vertex, and this right here is 2 things. One, it's reflected, the negative is, and then it's a factor, it's being shrunk by a factor of 3, or 1/3 of its size. So if we go 7 spaces to the left, and then 3 spaces down, so the vertex is right there, it's going to go down, and it's going to be a wider graph. So it's going to look something like that. And the reason, and then to be accurate, you still got to make an XY chart and find numbers. But when you graph it, now at least you know that you need to plug in numbers like -7, -8, -9, something like that, so that it's just not randomly plugging in numbers. You know exactly where that parabola is located, and you know what numbers to plug into the XY chart. But you can definitely, especially on a multiple choice question, you can definitely locate the parabola just by looking at the characteristics of it.